Hello friends. So this topic is related to force on a curved surface due to hydrostatic pressure. Many a time we observe that in a tank or in a vessel in which the water is stored is having curvature shape at the end of it. And in order to find out how much force is acting on it, sometimes in industry how much thickness of the material is to be utilized. It depends upon how much amount of force is acting on it. And if you apply more thickness of the material, then cost of the material will increase and your product will not survive in the market. So, in order to find out how much amount of force is acting at the curved surface, this theory is covered. In this theory, the force is found out by using the equation under root fx square plus fy square, and the position of it is found out by using the equation tan inverse fy divided by fx. We all know that the pressure from the hydrostatic fluid is given by the equation rho into g into h, so that the total force can be written in terms of rho into g into h into d. But as it is acting at the inclination part, at the curvature part, so it will have two components, dfy and dfx. Let's discuss about the dfx. dfx is equal to nothing but df sine theta, because df and dfy making an angle of theta, so that dfx is equal to df sine theta, where df is equal to rho into g into h into dA as per hydrostatic law, pressure into area into sine theta. So fx theoretically can be given by the equation rho g h into dA into sine theta, where from the previous theories you can also search my video on force acting or center of pressure for the horizontal, vertical and inclined plate. In that theory also we have taken this force equation, which is nothing but fx, which is acting at the center of pressure, which is rho into g into a into h bar, where h bar is the height till the center of gravity. In this case, it is the height from the free surface till the center of gravity of this C and D plate. So from the D point, the curvature starts, and from the C point, the curvature ends. Where Fy is the vertical force, and it is written in terms of dF into cos theta. dF is equal to rho into g into h into dA into cos theta. So it is rho g integration of h into dA into cos theta. But Fy can be given by the equation rho into g into V. V means volume submerged. In this case, the curvature surface is provided below the area of AEDB and BDCB. So it is a quarter area of the circle of radius CD and plus the rectangle area of ABDE. Such amount of water is pressuring in a vertical direction on this curvature surface. So it is equivalent to it. So ultimately, the Fx is given by the equation rho into g into h bar into A, and Fy is given by the equation rho into g into V, where F is the inclination and the theta can be given by the equation tan inverse Fy divided by Fx. Thank you very much. Have a nice day.